Girls, how are you doing? So what I'm doing here now is I'm starting with an old question, going way back to 2000, because it's a good question. It's got good algebra in it, and it's relevant to what we're at the moment. It's probably you probably don't have it in your exam papers, so I've put the question up on Schoology. So look at the Word document that's on Schoology. I think it's called Differential Equations, April the 1st. And that gives you the question. So I'm going to run through it anyway. So the first part, 10A, because it's an entire question that we can do. Some of the questions we can't do because they're substitution questions. Okay, so it says if x times dy dx plus xy times dy dx minus 1 equals 0. You're given this equation. It's question 10A in 2000. It says y is equal to 2 when x is equal to e. You've got to find, correct the two places of decimals, the positive value of y when x is equal to e squared. Okay, so that's what we've got to find. So let's have a look. Let's start with this. So we'll separate the variables. So here I'm going to take x times dy dx out because that's common to both. And in here we'll go 1 plus y. I'll bring the 1 over to the other side. I'll separate the variables now. So I'll leave this 1 plus y on that side with the dy. And I'll take the x over and the dx. Now integrate both sides. So this will become y plus y squared over 2 is equal to the ln of x plus c. I'm going to put in the limits. So y is 2 when x is e. So this becomes 2 plus 2 squared over 2 is equal to the ln of e plus c. So of course this left-hand side will become 4. The ln of e, e to the power of 1 of course is just 1 plus c, which means that c is equal to 3. So I'll put that value for c back into the equation. Y plus y squared over 2 is equal to the ln of x plus 3. Now you're not finished yet. You've got to solve the equation, which means you need a y equals. And it asks you in the question for the positive values of y that would solve this equation. Okay, so let's continue down through this. I've got to find the value of y when x equals e squared. So I'm going to do this bit next. So this will become the positive values of y. So I'll get y plus y squared over 2 equals the ln of e squared plus 3. So this gives me y plus y squared over 2 is equal to 2 plus 3. So this is y plus y squared over 2 is equal to 5. I'll double everything to get rid of that fraction. So y squared is equal to 10. Now I have a quadratic. Bring everything to one side and solve for y. So it's y squared plus 2y minus 10 is equal to 0. Can't solve that linearly. I'll have to use the minus b formula, which will give me y is equal to minus b plus or minus the square root of b squared minus 4 by a by c all over 2a. And when I solve that, I'll end up with minus 2 plus or minus 6.63 all over 2. Okay, gives me two values for y, 4.63 over 2 and minus 8.63 over 2. But the question specifically says positive values of y, so I'm going to ignore this one and I get 2.31. Okay, so that's the first part of the question. Now, the second part of the question, part B. We've got the deceleration of a particle moving in a straight line with a speed of v has a magnitude of 4 by e to the power of v over 6. The particle has an initial speed of 6. So you've got to find the time for the speed to decrease to 3. Okay, so let's start this fella off. So it's a deceleration, so it's minus a is equal to 4e to the v over 6. My limits given are that it's starting at 6, it's going to decelerate down to a 3, and you've got to find the time it takes to do that. That's called t1. Okay, so it's a deceleration. My limits are v and t. So this is going to become minus dv dt is equal to 4e to the v over 6. Okay, I'll separate the variables. This will become minus dv over e to the v over 6. I'll leave that 4 there on the other side, 4 times dt. So I'll bring up that v, and that will become minus v over 6 dv is equal to 4 times dt, and that's easier to manage. Okay, I'll integrate both sides and I'll put in my limits. My limits are going on the v side from 6 to 3 and on the t side from 0 to t1. Okay, so let's integrate that. I'll get minus. Now, e to the minus v over 6, and then that will be divided, of course, by minus 1/6. And that's equal to 4 times t. And again, my limits are going from 6 to 3 on the v side and 0 to t1 there. So I'll flip this minus 1/6 up. This will become plus 6 e to the minus v over 6. Same limits equals 4 times t. Okay, so I'll take the 6 outside and I'll say v to the e to the minus. This will become 6 over 6, so that will be to the minus 1. Minus e to the minus 3 over 6, of course, will be minus a half. And that's equal to 4 into 0 minus t1. So this is 6 into e to the minus 1 is 1 over e. E to the minus 1 over 1, e to the power of minus a half is 1 over the square root of e, is equal to minus 4 times t1. So I'll bring over that minus 4, and this will become minus 3 over 2 into 1 over e minus 1 over root e. I might get rid of that minus there outside, so I'll say 3 over 2 into plus 1 over root e minus 1 over e. That's equal to t1. Okay, so that's the time for the speed to decrease from 6 to 3. Now, the second part of the question says, find the time t2 for the particle to come to rest. Okay, so this time I'm going to just change the limits. That's all I'm going to do. So I have most of what I want there already. So I'll just change the limits. So the time to come to rest. So the limits will be from 6 to 3 again for 6 to 0 for velocity, and the time will be from 0, and I'll call this new time t2. Okay, so remember I already have this solved, so this is going to become 6 to the e to the minus v over 6, I already have, is equal to 4 times t, and all I'm doing, because I've already solved that, is I'm changing the limits. So from 6 to 0 and 0 to t2. And when I do that, this becomes 6 by e to the minus 6 over 6, which is minus 1, minus, this will become e to the 0, and that will be 4 into 0 minus t2. Okay, so this becomes 6 to the 1 over e minus 1 is equal to minus 4 times t2. I'll bring over that minus 4 and I'll get minus 3 over 2 again. 1 minus e minus 1. That's my t2. Second part of the question. Now, the third part of the question says, deduce that t2 minus t1 over t1 equals root e. So I'm just going to fill in my answers and my solutions to this equation and see does it satisfy it. Okay, so t2 minus t1, so the third part, t2 minus t1 over t1 is equal to the square root of e. Right then, so T2 is, and I'll change this now again, this T2 I'll say it's 3 over 2 into, this will become 1 minus 1 over e, that'll just be handier with my signs. So my T2 will become 3 over 2 into 1 minus 1 over e, minus T1 is 3 over 2 into 1 over root e, minus 1 over e. That's going to be over t1, or I might just bring the t1 to the right-hand side and multiply it by the root e. So I'm going to multiply t1 here, which again is 3 over 2, 1 over root e minus 1 over e times root e. Okay, the 3 over 2's will cancel all the way across, and this will become 1 minus 1 over e, minus 1 over root e, plus 1 over e, those 3 over 2's are cancelling, equals, I'll multiply that, well, I'll multiply it in a minute. So 1 over e, root e minus 1 over e by root e. So those 1 over e's will cancel, so I'll have 1 minus 1 over root e here is equal to, I'll multiply in that root e here, this becomes 1 minus root e over e. Those 1's will cancel, so I'll have 1 over root e is equal to minus root e over e. And if I cross multiply, I get minus e equals minus root e by root e is minus e. So that's proved. Okay, so that's that question.